In the bicycle frame building shop, especially when you're getting started and if you don't have a huge budget, you're gonna want a heavy bench and a nice bench vise, and then some hacksaws, hand files, and a couple other associated things. And as you develop more tools and experience, maybe you'll get a little bit away from doing everything in that spot, but in the beginning it is bedrock to everything that happens in the shop. That's how it was for me, and I think that's how it is for a lot of people. So I want to talk about that section of the shop and those tools. As I've mentioned in some other videos, I took a frame building class at the very beginning when I was getting started making bikes, and we learned a very traditional way to make bikes. I say we could have done the class almost the same way if the power had gone out, because most of everything we did was at a bench with a heavy bench vise, with hacksaws and hand files and tubing blocks and real simple stuff. That we didn't have sophisticated power tools and stuff, and it's a good way to learn for a number of reasons. So now in my shop I have a chop saw that I did a video about that rough cuts tubing to length, and I have machines where you do your mitering and a bunch of other stuff. I have a 1x30-inch belt sander that I can polish up the ends of the tubes, but all of those steps used to happen right here at this bench vise when I was getting started, and without this I wouldn't have been able to do anything. I think sometimes the pizzazz of other tools kind of steals the thunder, but a good heavy bench vise that's rigid and solid is really bedrock to what you do in the shop. And even as I got other machines that were more capable, that were faster, that were more accurate, whatever, this was still incredibly important, and I still use this all the time for all sorts of stuff. So the bench, first of all, is heavy, right? And I have it, I don't know, this whole thing weighs like 200 pounds. Me and my dad made this bench in 2012, and it's ash, and it's real robust. Then in addition to that, I have it screwed to the wall, but I can't hardly pick it up. Just barely, it's heavy. And it's also screwed to the wall on the back on the top of it. And so when I put something in here, whether it's bike tubing or whatever it is, and I'm either hacksawing or I'm hand filing, you're pushing on it. And if it's just this flimsy card table of a bench, a lot of the work that you're putting into it is going into just rocking the thing around. But when it's heavy and robust, it's more rigid and stiff, and that work that you're putting into the tool is going into your workpiece, and the cutting is happening, and that's what you want. It feels better. It's also just a lot more efficient. This bench vise, I think, is 4.5-inch jaw width. It's the Colombian, made in Cleveland, Ohio, and I got this for $200 on Craigslist. I had to look around, but there's old vices like this on Craigslist pretty commonly, at least in the places I've lived. And you can buy something new from the hardware store for a couple $100 or something. You can get a Wilton machinist vise, and those are real nice. They cost a lot of money generally, but those are the favorite of frame builders for sure. I always was jealous of all the other frame builders who had them. They have a really nice screw action, and they're very beautiful, and this works good enough for what I do. And so it has these, I don't know if you call them serrated, but these sort of rough, waffly jaws. I don't know if they're knurled, but anyway, it has these jaws, and it bites on stuff pretty well. I took just copper pipe, and I slid it down the length of it, and I guess I annealed it first. I heated it up with a torch hot, and then I dropped it into a thing of water. That's my understanding of how you anneal copper. I just watched a YouTube video. I don't know. But anyway, when you put copper over this, now you can grip onto stuff, and the copper it's usually softer than what you're biting, and it's softer than these jaws, and so it conforms a little bit. You still get a good grip, but you're not marring into the workpiece as much. I remember in the very beginning I had some dropouts, and I wanted to hand file them. I wanted to change the shape a little bit, and you could see that sort of waffle impression in the dropout. That was not acceptable. I didn't want that, so I made these jaws, and from then on, when I would grab onto stuff, especially something like the faces of a bottom bracket shell, you don't want that to get chewed up. And so these have gotten real chewed up, but this material is soft enough that it deforms before it would deform your workpiece. So that's a good component of the bench vise. And so you can put something in there and hold it tight, and you can get it done. The next thing I want to talk about is hacksaws. Now what you'll see at the hardware store cheap is, I don't even have one. That was my jaw falling off of the bench vise. These things piss me off. If you're gonna make some, think about how to make it wrap around and kind of stick in place. That'd be a wise thing to do so they're not falling off all the time. These have bothered me for years and I've been too lazy to fix them. When you go to the hardware store or any random person's toolbox, usually you're not going to see a hacksaw frame quite like this. The frame of the hacksaw is usually what makes it a good hacksaw. Certainly the blades wear out and you need to replace them, but if you don't have a high tension hacksaw frame like this, it's not going to have enough tension on the blade. It's not going to want to cut straight. It's going to be really frustrating. So you need one. I mean, all three of these. You can see I have 3 hacksaw frames here, and they're for different pitch blades. So I have the finest is a 32, and then this one here is a 24, and this one is an 18 tooth per inch. And so there's a reason I have all those, but you'll notice that the design of these is all similar. There's sort of a box, like a rectangular tube box section on top, and then there's like a cast handle on either end, and then there's a screw here that you tighten, and that allows you to get a much higher tension on your blade than the ones that are just like a stamped 1/8 inch metal or whatever it is, 1/4 inch or something, but it's not nearly as stiff as these ones that have a tube up on the top. So the reason that I have 3 different pitch of hacksaw blade ready to go is that when you're dealing with bicycles you have some thin wall tubing, and so whenever you're sawing anything you generally want to have more than one tooth engaged in the cut at any given time. Let me draw that on the whiteboard. So if this is the piece that I'm trying to saw, and this is my saw, you can see as I push the saw this way, I'm going to have multiple teeth engaged in the cut. Now you can imagine if I had a more coarse saw blade. So this is a more coarse saw blade relative to my workpiece, and what's going to happen is it's going to snag on that tooth. The piece is actually going to get up into the gullet of the saw blade, and it's going to snag on that tooth, and you're going to be very likely to break this tooth in a very short period of time. Not only that, when you go to push, it's just going to want to catch. And so you always want to have more than one tooth on the workpiece at a given time, and a couple teeth is good. If you have too fine of a pitch, then what happens is your gullets fill up with chips partway through the cut, and then they can't, there's no room for extra chip material in the gullets, and so a lot of the stroke you're just pushing the chips along and it can't take a bite. So you want to have some coarser blades for cutting through like thicker stock, and you want to have some finer pitch blades for like thin bicycle tubing. So if you had something heavy like dropout stock or something that's 1/4 inch or thicker, you're going to want the coarse saw blade, and something real thin, you're going to want the fine pitch saw blade. And just having 3 hacksaws, I mean, all 3 of these, if you went to the store, this is the only one I bought, well, I guess I bought both of these brand new at different times. This is like $25 or $30. So even if you bought all 3 of them, you're still under $100. Incredibly useful to have these ready to go. I would buy extra blades at the flea market for $1 each, but they really don't cost that much more than that. You know, get some decent bi-metal blades from, you know, wherever you get them, Lennox or Starrett or whoever, but, you know, some decent blades. They don't last forever, and just change them out when you need to. But having a good high-tension hacksaw frame and the right blade is going to allow you to make the cuts quickly and efficiently. So, in order to use the bench vise with the tubing that you make bicycles out of, you can't just clamp it in there. You'd be donezo in a second. It would just crush it, right? So you need a way to support the tubing while getting a good hold on it, and there's different ways to do that. The thing that I did immediately that's probably the most affordable and simple for DIY is to just get some hardwood. This is oak, but some sort of hardwood, and you drill out with like a spade drill or a large drill or whatever. You drill out the diameter of common tubing, which is just fractional inch, so inch and an eighth, whatever. And then you split it so that you have just about, you know, like 48% or something in here. You know, you want when it's fully closed there to be a little bit of gap here so that you can actually compress and still be holding the tubing. So when I made this, I think I had 2 halves, and then I sandwiched in with a clamp on it. I sandwiched in like a thin piece of cardboard or something, and then I put it in a drill press and I drilled it out. So that way, you know, when you remove the cardboard and you put a tube in there, you clamp it in the vise. it bottoms out on the tube, not against itself, so you can get some clamping force in there. Really simple to make these. You can use an old mountain bike tire, or I just had this piece of rubber with, you know, some drywall screws, and you put it together, and now you have this self-contained thing. You slip it over your tube, and you put it in the vise. And so now, this isn't going anywhere. I can really work on it. So, let's see here. Grab trusty Gene Hackman. If I want to make a cut off the end of this, I just kind of put my fingernail against here. And this is kind of a dull hacksaw blade, I can tell by looking at it. I like to start the cut with my finger there just to make sure that I don't skeeter off and, you know, mar up my tubing. And once I get just a little ways in, and hacksaws and hand files are the same, most people know this, it cuts on the push. On the way back, you're not really pushing into it, you're just retracting it, you know, but it really, you want to lean into it while you're pushing. And so, in pretty short order, I've cut through the tubing, and so I'd use a hacksaw to rough cut stuff to length before then I would miter it, or you can even sketch out with a marker the miter if you were, you know, if you were going to do that. You could use a lug, you could slide a lug on and kind of trace around it. That'd give you a rough idea of what your miter needed to be. And then you could bring it in with hand files or whatever, or if you're just rough cutting it to then miter it on a Bridgeport. You know, even for a couple years I had a Bridgeport and I would still rough cut stuff to length with a hacksaw because it takes 10 seconds. It's a really easy way to make a rough cut. It doesn't matter if it's kind of rough on the end. So that's the one huge use of this. The other thing is, you know, if you have a bicycle frame that you fillet brazed or you've brazed with lugs or something, you need to be able to file those. Generally people file that stuff after they braze it, especially fillet brazed bikes. And you can hold the bike frame in here, so you just have to kind of fish it in and around the vise. But now you have a solid way to hold it, and you get a rat tail file like this guy, and now you can file your fillets on the bike. And you can, another thing that I like to have right here at the bench vise for that sort of finish work is a roll of Emery Cloth. And so this is just 80 grit, that's the only one I have, but it's 1 inch wide, Emery Cloth. You know, it's sandpaper with cloth backing that comes on a roll. And a roll of this doesn't cost that much money. You can get a couple grits, so 80 is the coarse grit, and then you might want, you know, 150 or up to 220. You know, if through your experience you'll find what you need for the way that you like finishing stuff, what shows through paint, what doesn't. You know, if you're getting stuff powder coated, that's a thick and heavy plasticky paint, you're not going to see any of the file marks as easily as if you're using a nice thin high gloss automotive paint. It's going to show the file marks and the sanding marks more, and so you might need to be more thorough about that. But having that right here in the finishing area is really helpful. Before I would weld or braze this, I would want to take a strip of this Emery Cloth and then I shoe shine the end of the tube. And now you've removed any oxidation, any rust or anything off the surface. And if you want to wipe that with acetone or clean it with like Simple Green or something, that's going to be ready for brazing or welding, and it's gonna accept that sort of process a lot better than if you were doing it on the raw finish of the tubing, especially if it had mill scale, if it was like straight gauge tubing or something. You can use blocks like this to hold seat stays and chain stays and fork blades and things that are tapered. And so this isn't my design, and I mean neither is this, but this one's more clever. So this is something I think Dave Bohm made and sold, something sort of like this, and I've seen a couple people make these, but what I did for this was, again, this was probably ash or oak, it was some sort of hardwood, and I had access to probably my dad's table saw at the time, and so I cut it. And for both of these, the grain orientation of the wood is important. Here you want the grain running this way, so when you clamp it, if the grain was running this way, it would just split because it's got this load, and it would just, it's like driving a wedge in there, right? So you want the grain running this way, and you're looking at the end grain here. for this one, it's the same idea. If the grain was running this way, that V would just kind of be a log splitter. Just want to split this apart. And in fact, I made something like this earlier, and eventually it did split because I had the grain running the wrong way. So I made another one. And for this, you know, the grain is running this way, and it's much stronger to resist that log splitter sort of action. But what it is, you know, one V-notch is a little bit deeper than the other. I made this pretty much completely on a table saw. So, you know, I maybe chop sawed some of it out, and then I ran the table saw blade at an angle, and I just kind of pushed it through there, and I flipped it around, and you know, it's a little bit crude, but it works. And the one V is deeper than the other, and the same thing on this block, one V is deeper than the other. And I've dropped them on the floor enough to bang the corners off, but that doesn't really matter. And so, depending on the size of your tubing, if it's real small, you put the two small V's together. If it's medium size, you do the small and the large together. And if it's real big, then you do the large and the large together. And that allows you to, you know, accommodate a variety of tubing diameters. And then the brilliant part of it is that this side has an arc to it. And so if your tube has a taper, it kind of meets here. And if it's, you know, more straight, then it meets in the middle. But this allows you to clamp between the parallel jaw faces and apply a lot of pressure, and it distributes the load evenly so that you get a nice hold on your piece, even if it is tapered. If you didn't have this, if both pieces were flat, then it would just kind of pinch on the side with the larger diameter of the taper, and you wouldn't get very good work holding. So something like this, and then a series of these for fractional inch, it's going to make it real easy for you to hold your tubing. Another thing is, you know, I mitered this on the milling machine using a hole saw, which is great, but you know, a machine like that costs a couple grand. They take up a lot of space. I think they're worth having in the shop, but if you're just getting started, it might take you a while, and depending on the constraints of, you know, where you live and all that stuff, you might never have one. So if you need to, of course, a lot of people would put that miter into the tube. Well, I would hold it a little bit lower. You always want to choke up on stuff as much as you can. But I'd get it lined up here, and you can rough in the shape with a hacksaw if you want. And I don't do a whole lot of hand filing these days because I got all these machines and I'm doing other stuff, so my hand files are getting to be a little bit dull, but having a good selection of sharp hand files is just so valuable when you do so much work out of the bench vise. And when you're experienced with it and you have the good hand files, you can make a nice miter like this in just a couple minutes. Let me grab another piece and show you what I mean. If you had this and you wanted it to fit up against this, like on a head tube or, you know, any joint on the bike, you know, I just machine mitered this and then I put it in a drawer because with TIG welding I would like to do a practice joint from time to time. I haven't been making bikes very much lately, and so I wanted to have a bunch of these ready to go so that when I had 15 minutes at the end of the day, I could set up my welder and I could do a practice joint or two and I wouldn't get totally rusty. And just because, you know, I could use the improvement. You know, I'm not the best welder around. And so what you do is you take a little section of tubing like this, and if you're gonna you know, do it by hand, you need this, and there's another thing you need. Well, I can't seem to find my Bevel Protractor. I have a Starrett Bevel Protractor that's pretty sick, and you know, you can set it to whatever angle, and then you can actually set, you know, there's degrees, and then there's minutes of angle, and there's seconds of angle, and so there's 60 minutes in a degree, and there's 60 seconds in a minute, and so you know, you can divide a degree into a pretty fine amount. And so anyway, the tool is fairly accurate for physically measuring and laying out angles, and it's a good size for this sort of thing. It's called a Bevel Protractor. Anyway, if you have one of those, you can put the one edge against here and then the little swinging arm against here, and you can kind of check the angle as you're doing it. And then you have, you know, your little offcut of the right diameter tubing, and you just kind of set it down in the notch, and you're looking for any daylight through there. You know, you want to have less than a fingernail's gap for most things, whether it's lugged or fillet brazed or TIG welded. You generally want a really tight fit up all the way around. And this is just about good enough, but I would still touch this up with a hand file. This is how it came off the machine. The other thing you got to check for is how centered it is, you know, if you're getting off to one side or the other. But, you know, I used to do a lot of prep joints for for practice brazing and stuff years ago, and I didn't have a milling machine, and I would do them all by hand with hand files. And you know, you can get pretty quick at it. I think I've heard people say, you know, frame builders who use that method and don't have a milling machine, that they can do a quality miter that's ready to weld in like a minute or two with a hacksaw and a hand file. So if you develop that skill, it can be pretty fast and accurate actually. And you know, when you're working, you want to have the height of your vise about at elbow height. That's a pretty comfortable working height. So when you're building or buying your workbench, think about that, you know, sort of have it. If it's too high or too low, it's going to be awkward. So something like this is pretty good. And then you know, you just want to be comfortable as you work so that you can focus on what you're doing. But this sort of method really, it's pretty effective for getting started with frame building. Wherever it is in your shop that you find yourself working, especially if it's at a workbench like this, you want to just put the things that you need, you know, right where you need them, which is pretty obvious and intuitive, but you know, actually making a space for the things, actually putting the roll of Emery Cloth right there. And right now I don't use these tubing blocks very often these days, and I have them sitting up here, which I can barely reach. You know, I'm 6 foot tall, I can barely reach these things without knocking other stuff over, and that's not very ergonomic. The rest of it is pretty comfortable. So, you know, if you're doing, and this applies to a lot of things, right, but I would encourage people to take the time to set up the shop. You know, if you do a lot of hand filing, you know, just have your hand files right here. I've seen people actually make a rack to put them on the end of the bench. Some people have a freestanding vise in the middle of the shop with like a heavy post that is bolted down into the floor. That works too. You get a lot more room around it. One thing I want to point out about locating the vise is, I mean, first of all, you want to be able to get around it. So that's why I put it on this corner, as I'm right-handed, and so I like working on it like this, and I can get around it, you know, if I'm filing or whatever. And then the other thing is, if you look at the tube, it drops down and it clears the edge of the table here. And if you actually, you take a straight edge from this back jaw, you need to be able to clear the edge of your table. Anything that you put in here, you need to be able to hang down below the table. Don't make the mistake of putting it back. You know, you need to be able to hang it down there. And you know, it's pretty obvious, but if you're just putting it together, you might not realize that until you've drilled your holes and stuff. So that's most of what I got. You guys just gotta subscribe to the channel. Clem, what do you think about everybody subscribing to the channel? You think they should do it? She thinks that you should all subscribe right now. Thanks for watching.